Hi everyone, in Algebra 3 today we're going to be going over your questions on lesson 71. We're going to start on number 11, which is on finding the equation of a parabola whose focus is at 0, -2, and whose vertex is at the origin. Also find the equations of the directrix and the axis of symmetry and sketch the graph. So number 11, what I'm going to start by doing is I'm going to just start by sketching the graph. So we have a parabola whose vertex is at 0, 0 at the origin, and whose focus is at 0, -2. So this is our focus. The parabola always opens up to the focus, so it would look something like this. So right away, just looking at this equation, you actually know where your axis of symmetry is. It is right here at where x is equal to 0. So I'm going to say my axis of symmetry, which I usually just abbreviate as AOS, is going to be x is equal to 0. It's at the origin right here because it's exactly where your focus and your focus and your vertex line up on that x-axis. So now what we're going to do is we're going to find the directrix, and I know that the directrix is equal distances away from the vertex to the focus as the vertex to the directrix, so just in opposite directions. So this one is 2 spaces down, so that means the directrix is going to be 2 spaces up, but this one is going to be a line, a horizontal line through the y-axis. That's going to be your directrix. So we're going to say my directrix, it is crossing the y-axis at +2. So far we have 2 of our answers. We have our axis of symmetry, we have our directrix, we actually have our sketch. So the last thing we have to do is find our equation of the parabola, which will be in the form y equals 1/4p times x minus h squared plus k. Now, this h and k is actually just going to be the coordinates of the vertex. So our coordinates of our vertex are 0, 0. So I actually already know that h and k are going to be 0 and 0. The only thing I need to solve for is what p is equal to. And we can get that by our focus. So our focus is 0, -2. If you look over here at your little cheat sheet, it says h is equal, or h, k plus p. So my h is going to be 0, and my k plus p is going to be equal to -2. And I already know that k is equal to 0 because I said that this is the coordinate, the x and y coordinate of the vertex. So my k is actually equal to 0, which means that p is equal to -2. So when I plug all that information into this equation here, I get y is equal to 1/4 times -2 times x minus 0 squared plus 0. And 4 times -2 would be -1/8, so I'd have 1/-8, or -1/8 x squared, and that would be my answer because I don't have a k and I don't have an h. And that is your result. So we have 3 results actually, or 4. Your equation of your parabola, your directrix, your axis of symmetry, and then your diagram. Now moving on to number 12, a similar problem. It says the parabola has a vertex at 1, 2, and its focus at 1, 4. Write the equation of the parabola. Also find the equation of the directrix and the axis of symmetry and sketch the parabola. So just like on the last one, I actually want to start with my sketch. This one is going to be look something like this. So it's going to be 1, 2, so over 1 up 2. It's going to be your vertex. Your focus is 1, 4. So my parabola always opens up to the focus, so it should look something like that. Again, just like I said on the last one, you can come up with the axis of symmetry right away because it's where your focus and your vertex actually line up. So this is going to be the axis of symmetry is going to be at x is equal to 1. Then I'm going to look for my directrix because my directrix is just going to be the same number of spaces in the opposite direction of the focus. So 1, 2 spaces to the focus, which means I'm going to go 1, 2 spaces down, which is actually the y-axis, or where y is equal to 0. So I have my axis of symmetry and I have my directrix right there. Now I go on to the equation of the parabola, which is going to be y is equal to 1 over 4p times x minus h squared plus k. Now again, h and k is just going to be your vertex. So it's the coordinates of the vertex. In this case, it's 1 and 2. So I currently have y is equal to 1 over 4p, and that's going to be x minus 1 and then plus 2. Now I just need to find out what k plus p, or what the p is equal to, and that will come from the focus. So the focus coordinate is 1, 4. The equation for the focus is h, k plus p, which means that h is equal to 1, which I already said, and then k plus p is equal to 4. Well, I've already said that my k variable is equal to 2. Which means that p is going to be equal to 2. So I can plug that into here. So that would be 1 over 4 times 2. And your answer is going to be y is equal to 1 over 8 times x minus 1 squared plus 2. And that would be your result for number 12. So now looking at number 13, we're just going to change the format of this question. This is my log space, this is the number, and then y is your exponent. So when you change the format for number 13, it would be x is equal to 2.2 to the power of y. 2.2 is your base, y will be your exponent. So if I make an x and a y chart, I'm going to plug in -1, 0, and 1. Now this is going to be a little tricky because it's a decimal number. But let's just assume it's close to 2. So if we put this to the -1, that would be 1 over 2.2, which would be approximately 1/2. Anything to the 0 is 1. Then 2.2 to the 1 would just be 2.2. So I always plug in these variables, -1, 1, or 0, and 1. So I'm going to go over about 1/2 and then down -1, over 1 up 0, then over 2.2, and then go up 1. So I just went a little past 2. And that would be your diagram for number 13. So graphing the log, the key piece was just for me to change it from logarithmic form to exponential form. Now for number 14, we're going to have to solve by completing the square. So we're going to start by putting all the x's in parentheses and then moving the whole number to the other side. So 14, I'm going to have x squared plus 8x, leave a space, plus y squared minus 12y, leave a space, equals -43. When you complete the square, you take half of the middle term. So that would be x plus 4 squared. That squared is 16. And whatever you do to one side, you have to do to the other. So I'm going to add 16 to the other side. Then half of -12 would be -6. When I square that, I get 36, and I'm going to add that to both sides. So I'm going to have -43 plus 16 plus 36 will give me 9. Now, this is just the coordinate for the center of the circle. So that means that my center of the circle is going to be at -4, 6. My radius is the square root of the right-hand side, which would be equal to 3. So this diagram is going to look, yikes. So I'm going to go 1, 2, 3, 4, 5, 6, 7. Then 1, 2, 3, 4, 5, 6, 7, 8, 9. Dang it. So let's go over 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6. So it's about the center of the circle. Then the radius is 3. So 1, 2, 3. 1, 2, 3. So it'd be up to here, down to 1, 2, 3, which would be about here. And then over 1, 2, 3, which would be about here. And this will be your diagram of your circle. Mine looks kind of like an oval. And that is your result for number 14. So make sure you're not only completing the square to get the right equation, but you're also diagramming that as well. So now we're going to move on to number 15 and then number 16. And for both of these problems, we are going to be writing them as a cosine function. And I'm always going to go with probably a positive cosine function just because I like positive instead of negative. So for number 15, we have to find A, which is the midpoint. Then we have to find B, which is the amplitude. And then we have to find C, which is going to be your period length. So depending on if it's degrees or radians. So we're going to look at number 15. So on number 15, it looks like this. And so what we're going to do is we see the top point is -5, or is 5. The bottom point is -1, which means when we're finding the midpoint, we add the top and the bottom. So 5 plus -11 divided by 2. Then to find the amplitude, you always take the top number, 5, and then you're going to minus whatever you get for A. Then for C, you should see that this is in degrees. So I'm going to say my period is going to be 360 divided by the length of the period. Now the length of the period is kind of tricky. So what I'm going to do is I'm going to go to this, and I see that -40 is where it starts and it ends at 900. So the period length I'm going to calculate from 540 to 900. So 540 to 900. So now what I'm going to do is I'm going to go back to my paper. So I said 540 to 900. I'm still going to do some simple math here. So 5 minus 11 would give me -6. Divide that by 2 would be -3. Then 5 minus what I got for a -3, give me 8. Now this part over here, I have 540 plus 900 is 1440. So 360 divided by 1440 gives us 0.25, which in a fraction would be 1/4. So now I'm going to plug in what I have. I have y is equal to a, which is -3, plus b, which is 8, cosine c, which is 1/4. And this is where the phase shift comes in. So the phase shift is, where is it currently peaking? It's currently peaking at 180 degrees. I want it to peak at 0 degrees, which would be this y-axis right there. Whoa. So I will have, my phase shift is going to be 180 degrees to the left. 180 degrees to the left. So on my answer, it's going to be y equals a -3 plus 8 cosine 1/4, and then it's going to be x minus 180 degrees. And that would be my answer. So now what I'm going to do is I'm going to do the same thing for number 16. But this is going to be in radians instead of in degrees. So for number 16, I have to find A, the midpoint between the top and the bottom, B, is going to be the top minus the bottom, or top minus the middle. And then C, this one's in radians, so it's going to be 2 pi divided by the length of the period. So I'll show you how to calculate that as well. Okay, so now let's look at number 16. So my top and my bottom point are 3 and -1. So it's going to be 3 plus -1 divided by 2. Then for B, it's going to be 3 minus whatever I get for A. My period length on this one, notice how it starts at -pi/2 and then ends at 7 pi/2. So it peaks, then peaks again, which means my period length will be a total of pi/2 plus 7 pi/2. So you just add those 2 degrees together so that we can come up with our period length. So I just said that we would go, for the period length, it would be pi/2 plus 7 pi/2. I'll just pause on that right now. I'm going to go over to here. I have 3 minus 1 would be 2 divided by 2 would be 1. So 3 minus 1 would give me 2 for my amplitude. For C, I have 7 pi plus 1 pi would be 8 pi. So really I have 2 pi over 8 pi divided by 2 would be 4 pi. The pi's always cancel, so that simplifies to 1/2. So now my answer is going to be y is equal to 1 plus 2 cosine 1/2, and then my phase shift is going to be x, and then however many radians I have to move it. So it's currently peaking at -pi/2, and I want it to peak at pi at 0. So that means I need to move this over in the positive direction, move it to the right, pi/2. So I'm going to move it over to the right, pi/2. So again, my answer is just going to be x plus pi/2, because that's how many radians I want to shift it, and that would be your answer for number 16. Now moving on to number 17, what I'm going to do first for number 17 is I see that my whole number is negative and my I is negative, which means that this is going to end up being in quadrant 3 because it goes to the left of the origin and then down 8. So for number 17A, I'm going to have a triangle in quadrant 3, 7, 8, H, angle. So I'm going to find the hypotenuse using Pythagorean theorem. So h squared equals 7 squared plus 8 squared. Square root of 113. That does not divide, so h would just be the square root of 113. Now to find the angle, we're going to use inverse tangent of opposite over adjacent. In your calculator, it's going to be 8 divided by 7 equals, then second tangent, and that gives me an angle of 48.81 degrees. It's in quadrant 3 though, so I have to add 180 to that so that I know the distance from the origin to there. So I'm going to add 180, and that would give me a result of square root of 113 CIS 228.81 degrees. If you wanted to write the decimal number for that square root of 113, that also would have worked as well. Now for part B, I have to convert this from polar form into rectangular form. So what I'm going to do is I have to expand that CIS. So that means that for part B, I have 7 times cosine of 270 plus I sine of 270 270 is down on our unit circle, which is 0, -1. Cosine is equal to the x-coordinate, sine is equal to the y-coordinate. So this would become 7 times 0 plus -1i. So when I distribute the 7, my answer would be -7i, because it would be 0 minus 7i. So that one you had to use your unit circle instead of using a reference triangle. Now moving on to number 18, it's going to be a similar problem to the last one, but we have to multiply the outside numbers and add the degrees together. So for number 18, it's going to become 6, and then CIS -30 degrees. This 40 minus 70 would be -30. Now when I expand this, it's going to be 6 cosine of -30 plus I sine of -30, which is a reference triangle in quadrant 4. I'll just draw it over here. So if this is 30 degrees, this would be √3. This is -1, and this is 2. So the cosine of this is going to be adjacent over hypotenuse, which would be positive √3/2. Plus sine would be opposite over hypotenuse, would be -1/2. But don't forget your I. And then you're just going to distribute the 6. So that would be 3√3 minus 3i. So the 2 goes into 6. That's why we were able to simplify that. Now moving on to number 19. This is luckily already factored for us. So all we need to do right here is actually to set each of these parentheses equal to 0. Let's go right here. So I'm going to set the 2 cosine theta plus 1 equal to 0. And then I'm going to set the 2 sine theta plus √2 equal to 0. So now when I move the 1 to the other side, it becomes negative. When I move the √2, it becomes negative. Then I have to divide each of those by 2. So for the first one, I would have cosine theta is equal to -1/2. And for the next one, I would have sine theta is equal to -√2/2, but unfortunately that's not a reference triangle. So what I need to do is I need to move that square root of 2 down to the denominator. By doing that, I would multiply top and bottom by the square root of 2. So really I end up with sine theta is equal to -2/2√2, which would simplify to -1/√2. Which is a reference triangle. So that anytime you see that, you do need to move that square root down to the denominator if it's not a reference triangle. Now I need to find where cosine is negative. So I'm going to use my chart. All students take calculus. I know that everything is positive in quadrant 1 and cosine is positive in quadrant 4, which means that my 2 triangles are going to be in quadrants 2 and 3. My adjacent is -1 and my hypotenuse is 2, meaning that my 2 angles are going to be 60 degrees. So in quadrant 2, I would subtract 60 from 180, so that would be 120. In quadrant 3, I would add 60 to 180, which would be 240. Okay. Now for this next one, I have to find where sine is negative. So I have all students take calculus. Again, I said everything is positive in quadrant 1 and sine is positive in quadrant 2, which means that it's negative in 3 and 4. I have an opposite of -1 and a hypotenuse of √2, which you should know is a 45, 45, 90 triangle. That would give me quadrant 3 is going to be equal to 225 degrees. And then quadrant 4 is going to be equal to 315 degrees. Because you'd have to add 45 to 180 and then subtract 45 from 360. And luckily, they want the answer in degrees, not in radians. For number 20, what we need to do first is we see the squared. So we actually need to take the square root of both sides. When you do that, don't forget that you actually end up with plus or minus on that right-hand side. So for number 20, I would end up with cotangent x is equal to plus or minus the square root of 3. And we can always put that over 1. I'm going to split that into two equations. So I'm going to have cotangent x is equal to positive root 3 over 1. And then cotangent x is equal to negative root 3 over 1. Now, cotangent being positive will follow the same as where tangent is positive and negative where tangent is negative. So I have all students take calculus. Everything is positive in quadrant 1, and then tangent is positive in quadrant 3. Cotangent, though, is the inverse of tangent. So instead of opposite over adjacent, it's going to be adjacent over opposite. So that would be square root of 3 over 1, then square root of 3 over 1, meaning that this angle here is going to be a 60-degree angle. So for the first one, I would have 60 for quadrant 1, and for quadrant 3, it would be 240. Now I'm going to go to the second one. Well, where is tangent going to be negative? It's positive in 1 and 3, which means it's negative in 2 and 4. So the adjacent is going to be negative, or root 3, the opposite would be negative 1. The adjacent is negative root 3, the opposite is 1. And I just realized that I just messed that up. This one should be the adjacent is root 3. This should have been a 30-degree triangle. So the first one should be 30 and 210. The second one is going to be 150 and 330. My bad. And that should be your answers for number 20. Now moving on to number 21, the first thing that I want to do is I'm going to recognize that there is a cotangent in both of those terms that can be factored out, which would give me cotangent x, and then in parentheses, I'd have cotangent x plus 1 equals 0. So the first thing that I'm going to do is going to separate these. So cotangent x equals 0, and then cotangent x equals negative 1, because when you move the 1 to the other side, it's going to become negative. The left one is going to be the unit circle, and the right one is still going to be a reference triangle, because you can always put your numerator over 1. The unit circle I'm going to draw over here, so that would be 1, 0, 0, 1, negative 1, 0, and then 0, negative 1. Cotangent is equal to, instead of y over x, it's going to be x over y, which means we're looking for where the x is 0, and then the y is either 1 or negative 1. So if I underline all my x coordinates, I'm looking at these 2 degrees. And that would give me that x is equal to 90 and 270. Now for the second one where cotangent is negative, well, if I know all students take calculus, I know it's positive in 1 and 3, so therefore it's going to be negative in 2 and 4. And this is adjacent over opposite. So adjacent, opposite, Either way, that's a 45-degree triangle, which means that in quadrant 2, I'm going to subtract it from 180, which would be 135. And in quadrant 4, I'm going to subtract it from 360, which would be 315. And these should be your 4 answers for number 21. So it took some factoring before you actually solved. So number 22, we have negative 13 pi over 4. And we're doing the tangent squared and the secant squared of both of those. I'm going to start by making our snowflake chart here for 4. So 1, 2, 3, 4, 1, 2, 3, 4. Starting at 0. When we count negative 13, that means we're going to go start in quadrant 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That is actually in quadrant 2, and it's going to be a 45-degree triangle, where the adjacent is negative 1, the opposite 1, and the hypotenuse is root 2. When we take the tangent of this triangle, we're going to do opposite over adjacent. That's going to be 1 over negative 1, so negative 1, and we have to square it. The secant of this triangle is hypotenuse over adjacent, and that would be negative root 2, and we would have to square that as well. Negative 1 squared is 1, root 2 squared is 2, so that would be 1 minus 2. Your result is going to be negative 1. Now moving on to number 23. We have negative 480 degrees, which is greater than 360, so we're going to want to change that. So negative 480, we're going to subtract off 1 rotation, which means we should add 360, not make it bigger. So 480 plus 360 would be negative 120. So really I have sine squared of negative 120 plus cosine squared of negative 120. Now 120 degrees, negative 120, is going to be in quadrant 3. The 60-degree angle, so the adjacent would be negative 1, the opposite negative root 3, the hypotenuse 2. So the sine of this triangle is going to be opposite over hypotenuse, so that would be negative root 3 over 2, but we'd square it, plus cosine, which is adjacent over hypotenuse, so negative 1/2 squared. When I square this, this is going to become 3 over 4. And when I square this, is going to become 1 over 4. So our answer is just going to become 1. 3/4 plus 1/4 would be equal to 1. Now looking at number 24, I'm going to just squeeze this problem in here. We're going to start by just calculating what the median, the mode are. So this is 24, the median, and the mode. And then using our calculators, we're going to find the mean, the standard deviation, and the variance. Okay, so the median, if we count from the outside, so it's going to be between 3 and 5. The middle number between 3 and 5 would be 4. The mode is going to be 5 because it shows up the most. Now I'm going to start inputting things into my calculator. I'm going to do second 7, which clears it. If it says error, that means there is nothing stored in it. So I'm just going to click on and clear that. Now I'm going to input my variables into the calculator. So 1, 2, 3, 5, 5, and 7. So it should say n is equal to 6 because I've entered 6 variables into the calculator. Now to find the mean, you're going to do second x squared. That tells me that my mean is 3 0.83. For my standard deviation, I'm going to do second divide. Tells me that my standard deviation is going to be 2.03. My variance, I'm just going to square that, and so I get 4.14 as my variance. And that would conclude number 24. Looking at number 25, we are going to have to graph. So it says that x squared plus y squared is less than 9. That's a circle. And then this right here is actually a parabola. So this circle is going to be circled around 0, 0, and the radius is going to be 3. So let's just draw. Okay, so if the radius is 3, that means it should be a circle that looks like this, which mine looks like a really bad oval. The parabola is centered at 0, 0, over 1 up 1, and then over 2 up 4. So it should look something like this. Now, when it says that it's less than the radius, so this is a little different. So less than the radius means that it's going to be inside of the circle. So less than the radius, so it would be from the radius in. So that would be all of this portion, including this. Now, when y is less than x squared, less than means that it's everything underneath the parabola. So underneath would be everything not inside the parabola. It would be everything outside. So I would say that it would be all of this region. All of this, including all of that. So your answer is what's shaded by both, which should be inside the circle but underneath the parabola. And that would be your result for number 25. For number 26, we're going to have to do a very long finding the distance between a point and a line. So the first step is going to be to solve the equation for y. So for number 26, I'm going to have negative 5y equals negative 2x, minus 4. I'm going to divide everything by negative 5. So my first equation is going to be y is equal to 2 over 5x plus 4 over 5. It's not actually my first step. It's kind of like before my first step, because my first step is actually to find the perpendicular to this line that goes through this point. So step number 1, I'm going to flip it. So it's going to be negative 5 over 2x plus b. I'm going to plug in my x and my y. So I have negative 2 equals negative 5 over 2 times 0 plus b, which means that b is equal to negative 2. So my equation of the line is going to be y is equal to negative 5 over 2x minus 2. Now what I need to do is step 2 is to set these two lines equal to each other, my original line and my perpendicular line. So I have 2 over 5x plus 4 over 5 equals negative 5 over 2 x minus 2. I want to eliminate the denominator by multiplying this whole thing by 10, which would give me 4x plus 8 equals negative 25x minus 20. So if I move the this is going to be very ugly. So this is going to become 29x is equal to negative 28 So x is going to be equal to negative 28 over 29. Now what we have to do is we have to solve our equation for y by plugging this point into either original y or a perpendicular y. It doesn't matter which one. So I'm going to plug it into here. So that'll be y equals negative 5 over 2 times negative 28 over 29 minus 2. 2 goes into 28 14 times, so the common denominator is just going to be 29. So, wow. 14 times 5 would give us 70 over 29. Now 2 times 29, which gives me 58 over 29, which means that my y is going to be equal to 12 over 29. And we're not even done yet because we have to find the distance between our original point and these 2 points right here. So our original point and this point here. So I'm going to go to step 4 for the distance formula. It's going to take up a lot of space. So it's going to be, let's do x1, 0, minus negative 29. So I'm just going to do plus 28 over 29 squared plus negative 2 minus 12 over 29 squared. This just becomes 28 over 29 squared. I'm going to have 29 times 2 plus 12. It's going to be 70 over 29. I'm going to square that. So 28 squared, 784 plus 70 squared is 4,900 over 29 squared, which is 841. I hope my answer is right. So 4,900 plus 784 goes 5,684, which does not come out evenly. So I kind of don't think my answer is right for 29. Let me just check this quick. Check our answer key. So it's 71. Oh, this might be right. So let's do 5,684 divided by 29. Yeah, it is right. So this is actually 14 root 29 divided by 29 is your answer. So now we're going to look at number 27. So we are trying to find the area of this triangle in square feet. Notice that it's currently in centimeters though. So when I'm done, or I could do it before, I need to convert my answer from centimeters to feet. So it's up to you if you do it at the beginning or at the end. I'm going to do it at the end. So I have a triangle like this, where the base is 12, 8, and 28. So I am trying to find the height first. So I'm going to use sine for that. So it's going to be sine of 28 equals opposite over hypotenuse. So my height is going to be equal to 8 times 28 sine equals. So that would be about 3.76. But I'm going to leave my whole answer in my calculator. So I have the area of the triangle is 1/2 base, which is 12, times height, which is 3.76. 2 goes into 12 6 times. So really, I am just multiplying my height by 6. So I'm going to do times 6. And my current answer is going to be 22.53. But that's centimeters squared. So I'm going to leave this in my calculator because I need to convert this from centimeters to feet. So I need to multiply this by, I'm going to convert it to inches first. And then to feet. But don't forget that you actually have to square that. So I'm actually going to divide my answer divided by 2.54 squared, and then divide that answer by 12 squared, which is 144. So my actual answer for this is going to be 0.2 feet squared. So I chose to convert at the end. If you wanted to convert at the beginning, that works too. But that might have been the reason why you got your answer wrong on that one. So you need to make sure you're reading directions. Now for 28, I recognize that there's a number outside my logarithm. So those are going to become the exponents. And then it has that +1 on the outside, which is not attached to the logarithm. So I'm actually going to end up moving that over to the left-hand side. So I have, for 28, I'm going to have log of 8 of 16 to the power of 3 over 4 plus log 8 of x squared minus log 8 of x is equal to 1. So I move that log 8x over to the left-hand side. Now what I'm going to do is I'm going to find out what 16 to the power of 3 divided by 4 equals. And that's 8. So this would be log 8 of 8 plus log 8 of x squared minus log 8 of x equals 1. So I'm going to multiply these two together. Should be log 8x squared minus log 8x equals 1. Now because of this minus sign, I need to divide. So that would be log 8 of 8x squared divided by x equals 1. Now that I've gotten rid of or combined all my log 8s, I'm going to raise both sides to the power of 8. So really, I have 8x is equal to 8, which means that x is equal to 1. And that's all you have to do for 28. Now for number 29, for A, what you need to remember for ln of e is that ln is actually just a log with a base of e. So if I rewrote this, which you shouldn't, but this would be log e to the 1 minus log, and when there's no base, the base is assumed to be 10. So it would be 10 to the 1. So what you know is that these cancel because the base and the base are the same. Base and the base are the same. Really, we just have 1 minus 1, which is 0. So the ln would cancel out with the e, so it would just be left with the exponent. The log cancels out with the 10. You'd just be left with the exponent, which is 1. Now for B, I have ln of e to the third plus ln e to the 1/2. Now what I just said is that ln and the e would cancel. So for B, if the ln and the e cancel, the ln and the e cancel, I really just be left with 3 plus 1/2, which would be either equal to 7 over 2 or 3 1/2. Then on the last one, I have, this one's tricky. So 4 is just 2 to the power of 2. So when I rewrite C, I can do log 2 instead of 4, I'd have 2 squared. And then for the second part, I have log base 2 of 15 minus log 2 of 5. So I want to combine those first. So I have log 2 of 2 to the second plus 4 to the power of log 2 of 15 divided by 5 because of the minus sign. And then I want to change it so that this is 2 to the power of 2 as well, so that it can cancel with the log 2 and the exponent. So this would be 2 to the second. Over 5, which is 3. So that would be, this would be 3. So what this really is would be log 2 squared plus 2 to the log 2 of 3 squared, because this would be outside the logarithm, so it would become the power of. Now we can cancel the log 2 and the 2 and the log 2, and we'd have 2 plus 3 squared, which is 9. Result should be 11. So again, this is really just 2 times the log 2, because the 2 is on the outside, it becomes the power of the 15 over 5. And then lastly, we're looking at number 30. So for number 30, it says factor over the set of complex numbers, which means that you want a result of x minus root times x minus root. I need to find what those roots are by doing quadratic formula. So I'm going to have x is equal to -7 plus or minus the square root, 7 squared minus 4 times a times c, all over 2 times a. So I have -7 plus or minus, would have 49 minus 15 times 4 would be the square root of 11i all over 2. So now I have my 2 roots. So I have -7 over 2 plus root 11i over 2, or -7 over 2 minus root 11i over 2. And when you plug it in, remember those change from negative to positive and positive to negative. So my -7 becomes plus 7 over 2. My positive root 11 changes to negative root 11 over 2. My -7 again changes to positive 7 over 2. And my negative root 11 changes to positive root 11 over 2i. And that is your result. And that should conclude all of your questions on lesson 71. I hope you guys all have a great day. Bye.